My name is Kavish and I'll be presenting our work on locally guided global descriptor learning for 3D place recognition. Place recognition aims to associate input sensor data to a map or database of previously visited places. This task of global data association is essential to accurately close loops during simultaneous localization and mapping. Deep learning-based solutions for 3D place recognition define a network which maps input point cloud to a single vector representation to enable fast retrieval. These networks are trained using a contrastive loss applied at the global descriptor level. We note that in general, these networks can be decomposed into two distinct components, namely the feature extractor, which maps input points into high-dimensional local features, and the aggregator, which pulls local features into a single global descriptor. Given this decomposition, we observe that optimizing the network with a loss applied only on the global descriptor seems limiting. There are desirable properties of the local features which cannot be fully enforced solely by a global loss. To address this, as our main contribution, we propose to jointly supervise the local and global embeddings through the introduction of a local consistency loss. We demonstrate how the learning of local features which are consistent across revisits results in a more repeatable global descriptor. As additional contributions, we also introduce a sparse point voxel convolution-based backbone for feature extraction and a second-order pooling with differentiable eigenvalue power normalization for feature aggregation. During training, a tuple of point clouds are fed into a sparse conv unit to extract local features. The local consistency loss is applied to the anchor and positive point clouds. Local features are aggregated using second-order pooling to obtain the global descriptor. The final loss is the combination of the local consistency loss with the scene level loss. When applying the local consistency loss, we first align the point clouds using ground truth geolocation and estimate point correspondences using radius-based nearest neighbor search. We then minimize the distance between points features of corresponding points, and vice versa. For this, we use the point-wise hardest contrastive loss proposed by Choi et al. We validate our method through evaluation on the KITTI and MulRan datasets against handcrafted, hybrid, and end-to-end global descriptors. We first investigate the contribution of the local consistency loss through ablation on the MulRan dataset. The inclusion of the local consistency loss gives a consistent and significant improvement in performance, resulting in a 61% increase in mean F1 max when combined with equal weights. This demonstrates that the enforcing consistency of local features leads to an overall increase in the performance of the global descriptors. When comparing our method against other state-of-the-art methods, our method obtains consistently high performance across all sequences, even in the challenging sequences of KITTI-02 and MulRan DCC3, where other methods are brittle. The qualitative performance evaluation of our method shows the accuracy of top 1 retrieved candidates. On MulRan DCC3, our method successfully recognizes challenging reverse revisits with multi-lane translation offset, indicating its invariance to viewpoint. On KITTI-08, we again demonstrate correct top-1 retrievals during reverse and orthogonal revisits. Check out our project page for more details and code. Thank you.